Example 10 on page 160. The random variable x has a probability distribution as shown in the table below. And part A, given that Ex, the expected value of x is 3. Given that Ex, I want to capture it elsewhere, Ex, the expected value of x is 3, where write down two equations involving P and Q. Write down two equations involving P and Q. We have had the expected value of x. And of course we know the expected value of x we have known from the previous equation is sigma xpx. So by all means, we need first of all to create another column or another row that is going to give us the product of x multiplied by the probability of x. So 1 times 0.1 is 0.1. 2 times p, which is 2p. 3 times 0.3 is 0.9. And 4 times q is 4q. 5 times 0.2 is just 1.0. Forming two equations, of course, we know very well from all the examples that we have had that the sigma of the probability of x's is all obviously adding up to 1. That means 0.1 plus p plus 0.3 plus q plus 0.2 should give us 1. So 0.1 plus 0.3 plus 0.2 is obviously 0.6. So p plus q is 1 minus 0.6. So p plus q is 0.4. And that is the first equation. The second equation will rotate around that statement. The expected value of x is 3, meaning that the expected value is the sigma of xpx. What does that tell us? That 0.1 plus 2p plus 0.9 plus 4q plus 1, all these give us 3, which is the expected value. And it goes without saying that 0.1 plus 0.9 is 1 plus 1, which is equals to 2, which is equals to 2. And of course now, before we go further, it is important to note that 0.1 plus 0.9, that is 1 plus 1 is equals to 2. Given that now we have to be very accurate as far as that one is concerned. So 2p plus 4q is equals to 3 minus the sum of 0.1 plus 0.9, which is 1, plus 1, which is 2, minus 2. Therefore, 2p plus 4q is equals to a 1. And that is basically our second equation. That is how easily we can answer part A of the question. But there is a part B of the question which is telling us find the value of P and the value of Q. Well, it goes without saying, now we have two simultaneous equations. We have 2P, this is part B. We have 2P plus 4Q giving us 1, and as equation 2, and we have P plus Q giving us a 0.4. And of course, if we work the way we learned in year 9, year 10, and down there, of course, we must remember what the does used to do for us. And this one is used when you want to use the elimination method in simultaneous equations. And it means when we have different signs, we add. When we have the same signs, we subtract. Of course, here we are having same signs, but we must first of all balance the coefficient of the unknown to be eliminated. So by all means, we're going to have times 1 and times 2, so that this becomes 2p plus 4q is equals to 1. And this one is going to be 2p plus 2q is equals to 0.8. And this, if this is equation 3 and this is equation 4, then we can have 3 minus 4. Equation 3 minus 4. So that kills each other. So 4, we are going to have 2q is equals to 1 minus 0.8, which is 0.2. Divide by 2, divide by 2, and you realize that our q is 0.1. Having had that, then we can substitute this one in equation 1, and we have p plus 0.1 is 0.4. And our p is 0.4 minus 0.1, which is obviously 0.3. So our p is 0.3 and our q is 0.1. That is how easily you can go through that question. And there is no worry. We are now home. Thank you so much.